Okay, so let me turn everything over to Simon Ritter from Azul.
Okay, yes, so good evening, welcome. We are going to be talking about things after 8, is the title of the presentation. And so yes, I like to start these presentations by kind of polling the audience to find out what we're doing in terms of Java usage at the moment. So who here is using Java 8 in production? Yes, which is kind of what I expect to see. So who here is using, say, Java 11 in production, which is a long-term support release? Okay, so smaller number than I would have expected to see. Anybody using anything more modern than Java 11, so 12 or 13? Yeah, okay, you don't count because you work for Oracle. What about the other way? So anybody here still using 7? Okay, a few people, that's kind of what I expect to see. Anybody still here using Java 6? Okay, one person in the back there. Anybody using anything older than 6? No, good, okay. So this is very much what we tend to see at the moment, is that people are still using Java 8, and the adoption of Java 11 is, I wouldn't say slow, but it's taking longer in terms of getting people onto the next long-term support release. So let's talk about how things have changed. Now, I put this slide up because JDK 9 was a big change in terms of Java. And the reason I say that is because Oracle were very clear when they released JDK 9 that this was going to be the last major release of Java. And what they meant by major release of Java was one that had multiple years of development behind it. What we've seen since then is a switch to this much faster release cadence. So now we have 6-month releases, 2 releases every year, March and September. And so JDK 9, like I say, was quite a significant release in a number of ways, and we'll kind of come back to some other changes that happened with JDK 9 as well. So I borrowed this slide from Oracle, and I used to work for Oracle, so I figured they still owe me a few slides. And it lists all of the sort of significant changes that went into JDK 9. And I think there's about 86 when I counted them up. So about 86 JEPs that went into JDK 9. JEP being a JDK enhancement proposal. So I'm not going to spend very long talking about JDK 9 because obviously that was 2 and a bit years ago now. But there is one significant change in JDK 9, which is why moving from JDK 8 to JDK 9 or later is more of a significant change than it was going from 6 to 7 or 7 to 8. And that is modularity, the Java platform module system. And again, I don't want to spend too long on this because there's lots of other stuff that's happened since then. But it is worth just spending a couple of minutes talking about what this means in terms of Java. And really, when you look at modularity, you can think of it in 2 different ways. The first way is the modularization of the platform itself. This makes a lot of sense because go all the way back to JDK 1.0, and I do like to ask this question as well. Anybody here use JDK 1.0 when it first came out? Okay, yes, a couple of people, but not many. Right, so if you go all the way back to JDK 1.0, what you find is that there were 211, counted them, 211 public classes that you could use in the class libraries to develop your application. That was the libraries you had. Move forward to JDK 8, and there's a little bit more than 8,500, which is great for us as developers, because it means we don't have to write an ArrayList class, we don't have to write a semaphore class. All of them are provided for us as part of the standard libraries. But the drawback is that all of these things were added in a monolithic way. We had rt.jar with all 8,500 classes in that. And so JDK 9, modularity, was about saying, okay, let's take the big monolithic set of classes and libraries and break it up into more manageable pieces. So then we have modules. And if you think about it, we've already had the idea of grouping things together in Java right from the very beginning. So we take logically related classes and we put them into packages. Now we have modules where we take logically related packages and put those in a module. If you look at the OpenJDK, there are actually 75 modules that got broken up into. And this is really good because what it allows us to do is to select only the modules we need for our application and build a Java runtime that is specific to that application. I'll talk a little bit more about that in a moment. But as I say, we've got 75 modules in the OpenJDK. 24 of those are for Java SE, which is the sort of core part of the Java specification. There are two what are called aggregator modules, which are ones that don't contain classes and packages themselves, but only have references to other modules. Again, I'll kind of mention a little bit more about that later on. Bizarrely, the smart card module is part of that. It's just kind of a historical thing that it ended up in Java SE and it's still there and it has to be there, so it's just there. And then we've got 48, which is part of the JDK itself, so there's things like a Azul module, there's all sorts of different things like that. So that's kind of like the easy bit of modularity. Then there's the other bit of modularity, the bit that's not quite so popular. Because looking at rt.jar, 4,500 public classes. There are also quite a number of internal classes in there. Those are ones that are placed there to make the public ones work. And the most infamous of these is SunMisc-unsafe. Anybody here use SunMisc-unsafe functionality? Okay, yeah, a few people. Let me ask that question slightly different way. Anybody here use a third-party library or framework like Spring or Hibernate or Log4j or anything like that?
Yes.
Yes. So you have used SunMisc-unsafe, you just don't quite know it. And what Oracle wanted to do initially was to encapsulate those classes because they didn't want you to use them. And right from the very beginning, Sun and then Oracle have been very clear about this, that these are classes which are not intended for general developer use. But people have used them. And so when they said they wanted to encapsulate them, they found that it was going to break a lot of existing code. And so there was a lot of discussion on the email aliases, and the decision was made that they wouldn't make the default to have these things all encapsulated. They would sort of be, but there were command line flags and things that you could use to make them accessible for your application code. So that is one of the reasons why moving from 8 to 11 is more of a, or 9 or 10 and 11, is more of a task than it was moving from 6 to 7 or 7 to 8. So like I say, the good thing about modules is this ability to build runtimes for your application that only include things you need. And that's through JLink. So what you do with JLink is you say, okay, I've got my application, I want to build a Java runtime for it. And so you say JLink, module path, where the modules are, and you say, I want to add a particular module, in this case it's an application I created, and where you want the output of that runtime image to go. So, my image. That will build you a directory structure that looks exactly like the JDK. So you have a bin directory, you have a conf directory, you have a lib directory, and so on. If you go into the bin directory, having created that, and you run Java with the list modules flag, it will show you what you've got. And in this case, I've got Java base, which you have to have because that's the sort of key module that everything depends on. You've got Java logging, SQL, XML, and then 3 modules that I created, which is ZAP, Soup, and Zeta. The nice thing about this is it's very kind of relevant to the idea of microservices. You know, we're shifting to the idea of putting everything in containers, using Kubernetes to orchestrate all of that, and having the runtime inside the container makes a lot of sense. So rather than having a centralized JDK that different applications point at through Java Home, what you do now is you build a runtime specific to your application, your service, put it inside the container with the service and everything, package it up, and off you go. And if you look at the size of the sort of standard JDK, it's about 350 megabytes in size, the whole thing. If you use JLink, And especially if you take a very simple application, the simplest application like Hello World, you can shrink that down to really less than 10 megabytes in size. Now, clearly the more functionality you need, the more modules you need, it's going to grow in size. But there are all sorts of things you can do, like stripping the symbol table, you can remove manual pages, stuff like that, and really get literally an order of magnitude reduction in size of the runtime. So perfectly suited to the idea of microservices. Now, compatibility is a big thing. In the past, we have been used to compatibility, backward compatibility for Java being very, very good. Literally, you could take code that had been compiled on JDK 1.0, admittedly not all code, but you can take code that's been compiled on JDK 1.0 and run it unmodified without recompiling it on JDK 8, and it will just work. So there's no problem there. But as we move from JDK 8 to JDK 9, we have to be a little bit more careful. And this is what Oracle's product management actually say. They say, clean applications that just depend on java.se should just work. It's a little less reassuring than I would like to see. I would like to say it will just work, but the reality is they should just work. So part of that issue is the thing about modularity and the internal APIs, and possibly having to use some extra command line flags. But there are a few other things as well that we need to be aware of. And that's because JDK, with JDK 9, they started to do cleanup. And this is something that has been long overdue in Java. You know, next year, Java is going to be 25 years old. And when JDK 9 came out, what was that? Sort of like two and a bit years ago. So that was 22 years of Java development. Lots and lots of features had been added to the JDK. Nothing, pretty much, had ever been removed. And if you go all the way back to JDK 1.1, we had the introduction of deprecation. So API elements we deprecated, meaning that that would indicate that there was either an alternative that you should use in preference to that, or at some point the intention was to remove that element from the API itself. This is very logical because, you know, when we develop libraries, when we develop an API, yes, you want to add things, but you also want to get to the point where you might want to remove things as well. And again, I did some counting up, and I found that there are, in JDK 8, 453 JDK elements, that's classes, interfaces, methods, and so on, that have been deprecated. I'm sure if I ask you how many have actually been removed, the answer is
0.
0, yes, that's right, 0 have been removed. Which kind of makes you think, well, what was the point of introducing deprecation? If you're not going to delete anything, what was the point? But anyway, JDK 9, they actually removed some API elements. They didn't really go overboard. They removed 6 methods. That was it, 6 methods. And of course you look at that and you think to yourself, well, hang on, what did those 6 methods do that was so bad, which meant they were the ones that got removed? And it turns out that if you look at the sort of organic development of the Java libraries, as they added more and more classes to rt.jar, everybody who created a new class said, okay, I've got all these other classes in there that I can use, and anything there is up for grabs, so I'll just use whatever I need from that. And so you ended up with some very odd relationships between different parts of the system, which meant by removing those 6 methods, they could do a cleaner separation of the module system. So it was really about getting the module system more cleanly divided up in terms of the libraries. They did also remove a whole class from the Java Authentication and Authorization Service, and then they started also doing some cleanup in terms of removing some redundant features like JHAT, the hprof agent, all the sample classes and examples and things, they all got disappeared as well. JDK 10, they went a little bit further. They removed an entire package, 6 classes, 9 methods, and 1 field. So a little bit of tidying up starting to happen there. And this is going to continue in newer versions as well. So they've kind of started deprecating a number of quite significant features. CMS has been deprecated, and in fact CMS is being removed in JDK 14. because Oracle said, you've got CMS, which is the sort of lower latency garbage collector, but we've also got G1, and G1 is considered the replacement for CMS. Now, some people said, well, we find CMS works better than G1, so can you keep CMS as well? And Oracle said, well, we don't really want to maintain two different garbage collectors that effectively do the same thing. And at the OpenJDK Committers Summit that they had, and also at the JVM Language Summit, Oracle were very kind of reasonable about this, and they said, well, yeah, if somebody wants to step up and maintain CMS, we will leave it in the OpenJDK. Everybody put your hand up if you want to maintain that. And you can guess, nobody was prepared to maintain CMS. So Oracle said, fine, if nobody else wants to do it, then we're not going to do it either. So that's going to happen. NASFORD has been deprecated, the scripting engine for JavaScript. PAC 200, again, that's going in JDK 14 as well. And I expect that there will be some other fairly major features that may get deprecated in the future as well. So, the key thing here is that compatibility is not guaranteed in the same way that it used to be, which means that when we move from one version to another, there may be breaking changes. And Oracle, again, be very clear about this. What Oracle have also done is they've said very clearly that they will make sure that you are warned about these things. Deprecation will be used. Anything that is intended to be removed will be deprecated first. And they have very graciously said that they will give us a minimum of one release warning before something is actually removed, which is good of them, because if it was less than one release warning, it would be no warning at all. But what that does mean is potentially a feature could be deprecated in one release and 6 months later it's gone. Probably not going to happen very often, but that is something that could happen. Okay, let's look at what's happened in more recent releases. So JDK 10. Now JDK 10 was the first release that only had 6 months of development. So there was bound to be less in terms of functionality being added, but there were still some interesting things that went on there. And what we saw is the introduction of local variable type inference. Now this is the kind of thing that we're used to seeing in Java at the moment. If I want to create a list, which is an array list, I can do something like this. So I can define an array list of type string, use a list, and then I say that I'm going to instantiate an array list, and I'll use the diamond operator, so I don't have to say the generic type both times, and then I instantiate a new instance of that. And I can then retrieve a stream from that, a stream of type string. I can also use local variables in for loop. So in this case, I've got the more modern for each way of doing things. So I've got the string name over user list, and then I can also use the old style way of doing for loops, where I've got for each I 0, I less than 10, I++. Great. With local variable type inference, Java gets var. So this is great because JavaScript has var. So if we add it to Java, it must be good, mustn't it? And now what we can do is we can say var user list equals new array list. And importantly here, if we're going through our code and we're making changes to use var, you have to remember that if you have used the diamond operator, you need to make an additional change because you need to add that generic type parameter in. If you don't, you get double type inference. The first type inference will be of the diamond operator, and that will infer object. So you'll get an array list of object, then you get the type inference of the actual variable itself, which will be an array list of type object. So if you are just going through and changing things to use var, you need to make sure that if you're using the diamond operator, that you add the generic type in to avoid the double type inference. So the compiler can then obviously figure out that user list is going to be an array list of type string. Similarly, when you retrieve a stream from that list, the compiler will easily be able to infer that that is a stream of strings. Similarly, we can use var in our for loops, and we can say for var name over user list, and the compiler will infer that that's a type string. And then finally, we can say for var I equals 0, and it will infer int. Do not do this. It makes no sense. int has 3 letters. var has 3 letters. There is no point in switching int to var. It just kind of confuses things. So the important thing about this is there are good places to use local variable type inference, but there are also some places where you will not use it. And so there are lots of documents written about this. One of the good places for local variable type inference is cleaning up code. Now, this is a try with resources block, and I've deliberately made this a very verbose piece of code. So what I'm doing here is I'm getting a buffered reader. I get the buffered reader from an input stream reader, and I get the input stream reader from an input stream. So I've kind of lots and lots of replication, input stream, get input stream reader, input stream reader, blah, 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 blah. Lots of replication, and it's all very messy. If we use var, we can tidy that up quite nicely, and it becomes a lot easier to see what's actually going on. So this is a good example of the use of var. Now, one of the things about var is it is a reserved type, not a reserved keyword. What does that mean? Well, if it was a reserved keyword, it would mean that we couldn't use var as a variable name, but we still can. So we can have var equals new value added reserve. That is perfectly valid, it will work. Compile. What we can't do in JDK 10 that we could have done in JDK 9, but we never would have done, is to create a class called var with a lowercase v. So that won't compile in JDK 10, but it would have compiled in JDK 9. But of course, we can still use the proper way of doing things, which is to use var with a capital V, and that will still work quite happily. So that's just the difference in terms of reserved type, not reserved keyword. In terms of JDK enhancement proposals, I haven't listed all of the ones that went into JDK 10 here. I've just picked a few that are ones that are a bit more interesting. So Jet 307, they added a parallel phase to the full collection of G1. What people were reporting was that because that was a single-threaded way of doing things in the past, throughput wasn't as good as it could have been, especially when you compared it to the parallel collector. So they decided that they could actually break things up into multiple threads, have it happen in parallel, and get better performance out of that. Application class data sharing was previously a commercial feature that was included in JDK. And the idea of application class data sharing is that when you start your application, the JVM has to read the class files for your application code. It does that, it builds some internal data structures based on the contents of the classes. When you start your application again, it has to do the same thing. It has to read the same class files, build the same internal data structures. With application class data sharing, you start your application up, and then you can tell the JVM to record those internal data structures for the classes. So you write it out to a file, and then when you start your application again, rather than having to reread the class files, you simply get the JVM to use that file, map it into memory, point the thing at the relevant place, use those data structures, and it reduces the startup time associated with your application. The other nice thing is that if you have several instances of JVM running the same application on a given machine, you can simply share that area of memory that's memory mapped in, and because it's read-only, you don't have to worry about changes to it, and therefore you can reduce the number of resources that are required by all of those JVMs. JDK 10 introduced an experimental Java-based JIT compiler called Graal, not to be confused with the Graal VM. Why Oracle decided to call both of them the same name, I don't know, but they did. It just makes life a little bit confusing. They should have called Graal VM the Substrate VM, which is what the code name of the project was in the beginning. But anyway, so this is a Java-based JIT compiler. And the idea is a replacement for C2, the more heavyweight JIT compiler, with the idea that you can generate more heavily optimized code and get better throughput for your application. And the last one that I picked up here is heap allocation on alternative devices. This was a JEP that was introduced by Intel. Intel are doing memory or non-volatile RAM, which has pretty much the same performance characteristics as dynamic RAM. And so what they wanted to be able to do was to say, you could put your heap either on dynamic RAM or on non-volatile RAM. JDK10 had some new APIs. In fact, I found 73 when I counted them up. And I didn't go through all of them, but some of the ones that are more interesting are ones around unmodifiable collections. So the list, set, and map interfaces all now have a new static method on them, copy of. That takes a collection and returns an unmodifiable instance of the same collection, so you can't change the elements in it. Similarly, for streams, the collector's utility class now has 3 methods that will give you an unmodifiable list, map, or set from the input stream as a result. And they also introduced a new method in optional, which is or else throw, which does exactly the same as get, it just has more letters in it. JDK Lemon. So this is the current long-term support release of the JDK. And long-term support release is something that Oracle introduced for the Oracle JDK. All the other providers of open JDK binaries are following the same approach. So it is pretty much the LTS release of everybody's builds. First thing they did was they extended local variable syntax. They extended it to being able to use it on lambda parameters. What's that do? Well, let's look at an example here. I've got a lambda expression in my map method, and what I'm doing here is I'm mapping from string to the lowercase version of the string. Now, if you look at that, you will notice that there is no type involved. That's because one of the big things with lambda expressions and strings was they reworked type inference, so you didn't have to explicitly put a type on S. But in JDK 11, you can now use var. So you could do this. You could say var S, S to lowercase. Why would you do that? What possible benefit does it have to you? Because it doesn't actually add anything. We already have type inference. Why do we need type inference again? And the answer is, there is one situation where you would use that. And that is if you want to have an annotation on the local or the lambda parameter. Because if you want to have an annotation on that, you must have a type involved as well. You could put the type explicitly, but if you've got a complex type, then you can just use var and do it that way. So it's a small change, but one that allows you to do that with lambda parameters. Launching single file source code. Now, the idea behind this was to make it easier for people to get started with Java. And if you think about writing your very first Java program, there's quite a lot of what they call ceremony involved in it. You have to edit a file, then you have to create a public class, then you have to create public static void main, string, args, and then you've got to do whatever you want to do in your code. Then you've got to compile it, then you actually get to run it. So there's lots of work just to get the first program running. If you look at JDK 10, there are 3 ways of starting an application. First is you can use the class path and you can use a class file. So you do Java by class. Second way is if you configure your jar file correctly, you can do Java minus jar of a jar file and it will execute from there. Because we now have the module system, the third way is to say Java minus M and the module that you want to start your application from. In JDK 11, we have a 4th way, which is that you can launch a class declared in a source file. So you can say Java factorial.java and then give it a parameter 4. What the JVM will do is it will look at that factorial.java file and say, hang on, that's not a class file. It doesn't have the magic number at the beginning. And it will say, aha, it is a Java source file. So it will compile the Java source file, generate a class file, hopefully, without any compilation errors, and then it will execute that particular class file. So it saves you the step of having to actually run the compiler on your source file. And you can then be even cleverer, and if you're using, say, Linux, for example, you can use shebang support, and you put your source code in there, and the top line you can say, okay, hashbang where my Java executable is, add the extra command line parameter to tell it what level of source code it is, make that file executable, and then you can just do /factorial 4, and the underlying operating system will say, aha, run Java on that, Java will look at it, it will compile it, it will then run the resulting executable and generate the result for you. So it kind of simplifies things. It almost makes Java like a scripting language, but not quite. A few other selected JEPs that went into JDK Lemon. First of these was nest-based access control. And this is part of a larger project, which is Valhalla. And I'll talk a little bit about Valhalla towards the end. Nest-based access control is something which you don't actually, doesn't have any impact on you as a developer. It's purely the way that the JVM and the compiler deal with things. If you have an inner class in your code, the inner class can access variables from the outer class, even if they're private. So there's a way of doing that. And the way that the compiler, the way that the JVM handles that, had to be changed in order for some of the other work that was going on to be done with Valhalla. So it's not something you actually see a change in terms of your development or your actual code. It's just an underlying change that's required for a bigger project. Second thing, dynamic class file constants. I always like this because it's like dynamic constants. That doesn't really make sense, does it? It's either dynamic or it's constant. It can't be both. But it can. So what they're doing here is providing more flexibility for people who are developing languages and compilers that are not Java to compile into bytecode to run on top of the JVM. Now we saw this in JDK 7, where they introduced the invoked dynamic bytecode, which was about making it easier and better performance for dynamically typed languages that were compiled into bytecodes. So dynamic class file constants is sort of related to that. And class files, funnily enough, have constants in them. But what they allow you to do now is to effectively treat them like think of it like a final variable in Java. So it's something which you can set once, but once it is set, it is then static. So it's dynamic in the sense that it's not set initially. You can do something to figure out what the value is, but once you set it, it then becomes fixed and you can't change it. So that's why it's both dynamic and constant. It's dynamic before you set it, constant afterwards. The epsilon garbage collector. Interesting one, this, because it's a garbage collector that doesn't collect any garbage. So you kind of go, okay, what's the point of that then? Don't see the relevance of that. But there is two reasons why they introduced that. In fact, this came from Alexei Shepelev of Red Hat, who has been developing Shenandoah, which is a different garbage collector. And the reason for having the epsilon garbage collector was primarily to determine the performance impact of different collectors. So what you could do is you could say, okay, run my sample application with the epsilon garbage collector, so no garbage collection happens. You've got to get a baseline for your performance, assuming you don't run out of heap space. Then you do the same benchmark, same test, but with your new garbage collector, and then you can see the delta between the two runs in terms of performance, and that shows you what the impact of your garbage collector is. And by changing the way the garbage collector works, or different garbage collector, you can see different effects of that. Some people have said that for things like the serverless computing, I thought, well, that is such a bad name for something. Serverless computing, where we have Lambda function type things from AWS. Very short-lived activities, primarily stateless activities. If you write those in Java, epsilon garbage collector could be quite useful because they're so short-lived that you may not need to actually do garbage collection for the lifetime of the app, that particular service. HTTP client, this was an incubator module in JDK 9. It's now being moved into the full standard, so it's really just a sort of technical change. TLS 1.3 is just really kind of bringing up the transport layer security to the most up-to-date and relevant way of doing things, and also the introduction of another garbage collector, ZGC, or as you Americans like to say, ZGC. And this is an experimental, low latency latency y garbage collector, which is targeted at things where you don't want garbage collection pauses interfering with your application. Now, it's an interesting idea. Basically, what they've done is to copy, in many ways, a lot of the work that we've done at Azul with our C4 collector. They don't do it quite the same way, so they're not truly pauseless. There are still some pauses involved in that. And it is very much experimental. I wouldn't recommend it in production, not just because they're competing with us, but also because people I've spoken to, they say they get fairly good results with it when it doesn't crash. So it's probably not a good thing to be using in production. A few new APIs in JDK 11. Some interesting ones here. So null input stream and null output stream. Null input stream is one that you can read precisely 0 bytes from, and null output stream is one that you can send as much data to as you like, and nothing will happen to it. So it's kind of like /def/null. And I must admit, when I looked at these, I thought to myself, I've been using Java for 20 plus years, never had need of these. So why did they add them? And it turns out that there are certain situations where if you're using streams and lambda expressions specifically, that you, because of the sort of functional nature of that style of programming, there are situations where it can be useful to have null input stream and null output stream. So those are added for that kind of convenience. And optional has a new method called isEmpty, which obviously is the opposite of what is present. String has some new methods as well. So string has come in for some love in JDK 11. First of those is blank. I'm not going to tell you what that does because it's kind of obvious. The second one is a lines method. If you have line breaks in your string, you will get a stream of strings broken up by those line breaks. Repeat does exactly what you would expect. It repeats the string a number of times that you specify. And then you've got these three methods, strip, strip leading, and strip trailing, which remove white space from either the beginning of the string, the end of the string, or both the beginning and the end of the string. Okay, that's great. The smart people amongst you will obviously go, well, hang on, we have trim in string already. So what's the difference between trim and strip? And the answer is how they treat white space. So if you look at trim, trim uses a very simple definition of white space. Basically space, tab, new line. Strip, strip leading, and strip trailing all use the Unicode definition of white space, which includes lots of other characters, most of which you've never heard of. So it's like vertical white space and things like that. My favourite feature in JDK 11 is a new method on the predicate interface. And the method is not, which takes a predicate. What does this do? Well, if we have something like this, so I'm filtering on a string of strings, and I'm using a lambda expression that says take the string and filter out all the blank lines from that string. What we can now do is we can use our new method, and we can say filter predicate.not, and then we'll use method reference, and we'll say string is blank. And if we do a static import on predicate.not, we get filter not string is blank. So it just makes the code a little bit more readable, a little bit simpler to understand. So I quite like that as a new method. JDK 11. This is quite important. Another reason why you may see issues in terms of moving code from JDK 8 to JDK 11. In the case of JDK 11, they have removed a significant number of existing APIs. And one of those was the java.se.ee aggregator module. So this is an aggregator module that referred to 6 modules that I've listed there. Corba. Anybody here using Corba? One unlucky person. Okay, right. So Corba has gone from Java as of JDK 11. In fact, it really kind of went away in JDK 9 because they essentially turned off these 6 modules. They were still there, but they turned them off for compilation and for runtime. But you could turn them back on again. But now they're completely gone as of JDK 11. Java activation is the Beans activation framework, and then XML binding, JAX-B. Anybody using JAX-B? Okay, one person, okay. And then the one that does seem to catch out a reasonable number of people is JAX-WS, which is the old SOAP-based way of doing web services rather than the more modern RESTful web services. Now, with the exception of Corba, this is fairly straightforward to replace these. You can just change your Maven POM file, and Maven Central has copies of the relevant modules for you, or you can get the reference implementation from the various JSRs. But it is reasonably easy to fix this problem. JDK 12. See, we're moving at a fair pace now in terms of development. What do we get in JDK 12? Right, this is interesting because now in JDK 12 we have switch expressions. And the reason this is an interesting thing is because this was the first preview feature that was included in Java. And a preview feature is one that becomes part of the language that you can use, but it's not part of the Java SE standard. So that's a sort of rather a strange thing, because it's part of the language, but it's not part of the standard. So technically you go, well, that doesn't sound right. But the way that they do this is that if you want to use this, then for both compilation and for runtime, you have to specify a flag that says enable experimental feature or enable preview features. And that way you have to deliberately tell the compiler and the JVM you want to use these things. So it's not part of the SE standard. And the idea behind that is so that if a feature needs some changes, they can do it without having to go back and change the standard. So it's allowing people to provide feedback, allowing people to say, yeah, well, this is a good feature, but it needs to be changed slightly, and then they can make those changes without having to adapt to the standard. So in the case of the switch expression, we've had switch for a long time, right from the very beginning. And switch has been a statement. Statement means that you can do something, but you can't assign a result from it to a variable. That's what an expression is. And the switch statement has had a number of things, because it came from the C programming language. There were things which are not ideal for Java programming. You know, the fact that you have to have separate case statements, the fact that you have to have a break for each case block, and okay, who here has never forgotten to put a break statement in their case? Yeah, okay. Because I know I have. And you end up with these really difficult to find bugs, don't you? Because it's like, no, it shouldn't go through there. And then you go, I forgot the break. Anyway, so that was one of the things. And then also, the scope of local variables is sometimes not intuitive as well. So this is the old-style way of doing a switch statement. And this is a very common pattern for the use of that, which is that we want to switch on a variable, and then we want to assign something else based on that value. What I've got here is days of the week. So I'm going to switch on the day of the week, and then I want to assign the number of letters in the name of that day to my variable. So I create a variable, and then I say switch on day, case Monday, case Friday, case Sunday, assign number of letters to be 6, remember to put the break in, and then obviously Tuesday is 7, and so on. So this is a very common pattern, but has a number of things which are not ideal about it. Firstly, there's the idea of the break that we have to remember to put in, but also in each block we have to remember to make the assignment to that variable. So there's lots of places that we have to remember to do things. And if we make changes, we have to be very careful about how we make those changes, not to have unwanted effects. Using a switch expression, we can rewrite that in a much simpler way. So now we can assign the result from the switch to the number of letters variable. So we do it once, and therefore we don't have to remember to do it in every set of case statements, and it becomes much more robust in terms of the code. The developers of this particular feature spent a lot of time working on this, and they discovered there was this incredible piece of technology that had never been exploited before in the case statement, which is a comma-separated list. So now we can do case Monday, comma, Friday, comma, Sunday, which is great because then we don't have to have separate lines with case. And then they borrowed some of the syntax from the Lambda expressions, and they used the arrow operator and said, okay, the thing that's on the right-hand side of the operator is the value that will be returned from that particular sort of case values. And so we end up with a much simpler piece of code, much more condensed, easier to see what's going on, easier to see how things are working and avoid errors with that. What we can do is we can combine the old style of doing things with the new style of doing things. And we can still put our case statements on separate lines, but in this case, rather than having a return, because obviously if we used return, we'd be returning from the method that this was in. So if we want to return a value from the switch expression, the way that we do that is by doing break and then the number that we want to return. And that's what gets returned into number of letters. And then obviously we can do that for all the different values there. And then if we want to be really complicated, we can combine code blocks in here. So we can have case 1 and then we can have a block of code, case 2 and we can have a block of code as well. And this also solves the problem of the scope of variables, because in this case we can have var x in case 1 and var x in case 2. You couldn't have done that in the old way with the case statement. So it allows you to do things like that. JDK 12, a few selected JEPs. First of these was the introduction of the Shenandoah garbage collector. Again, as I said, this was something that's being developed by Red Hat, Alexei Shiplev, Christine Flood are working on this. This is still experimental, so again, it's somewhat not recommended for production environments. I mean, you know, some people are using it, but it still is considered an experimental one. A couple of updates in terms of the G1 garbage collector, so things to again improve performance of these things. Abortable mixed collections is where if the garbage collector realizes it's spending too long in a particular phase of doing garbage collection, it will actually kind of break out of that phase in a safe way. So it will have said, okay, I've collected enough space to be able to allow the application to continue. I don't need to go through all of the regions, which is what G1 uses, so it can break out of that in order to avoid having too long reports. And then quite significant is the ability for the JVM to now return unused committed memory to the operating system. In the past, if you had an application where you configured the heap to be, let's say, 8 gigabytes, and you sort of used, let's say, 7 gigabytes of that space, but now your heap has sort of shrunk back and you're only using maybe 1 gigabyte, rather than hanging on to all of that space which is being unused, it will be given back to the operating system and can be used for other things that are going on that machine. So that's quite a useful thing. JVM constant API, that's really just an API that is for the dynamic constants so that you can access those programmatically, and default class data sharing archive for the standard libraries so that you don't have to make that yourself as part of the using class data sharing. Streams has an interesting new collector in JDK 12, which is called teeing. Now, teeing takes two collectors and a by function. And so I've drawn a nice little diagram here to illustrate how that works. What happens is you get your stream and it gets duplicated, so you've got two identical copies of the stream. Those get passed into the two collectors that we've specified as our parameters, and the results of those two collectors are passed as parameters to the by function. The by function takes two inputs, and whatever the function does, the result of that is what you get from the collector. Now, that's all well and good. We see how that works, but let's look at an example of what that might actually do. So in this case, what I'm doing is I'm saying, okay, take a stream of numbers. So I've got 145, 217. Pass those into collect as my terminal method. Use the teeing collector. And the first collector that we'll specify is summing double. So we'll add the values of all the elements on the input stream. The second collector is counting. So that will tell us how many elements there are on the input stream. And then the by function is simply to take that total sum of all the values and the number of the values, divide one by the other, and that will give us the average of the input values. Now, clearly, we could have done that with a single method called but, This is just a way of illustrating to you that that's the kind of thing you can do. That you can do much more complex things there. JDK 13, bringing you right up to date now with the current release of the JDK. Now, I have to say, JDK 13 was not really a very big release in terms of functionality. In fact, it was, I would say, without a shadow of a doubt, it was the smallest release we've ever seen of Java. We got text blocks. Okay, so a change to the language. And this is something, again, this is a preview feature. There was some work that was done back in JDK 12. They were going to do a different way of doing string literals for multi-line strings. And this has always been an issue with Java, the fact that you can't define a string that goes over a line break. But now you can with text blocks. So a text block starts with 3 double quotes. And then everything that follows those 3 double quotes up to the next set of 3 double quotes is treated as a string. Line breaks, special characters, doesn't matter, so that's part of a string. Obviously, if you want to have 3 double quotes in your string, then you have to escape at least the first one. You can escape the second one and the third one if you want to, but you have to escape at least the first of the 3 double quotes. So in this case, what we're seeing here is a little piece of HTML code. And if we print that out, what we'll see is this. And the reason that we don't see the indentation is because of what's called incidental white space. And this was quite a long discussion about how this should all work. Because obviously when you're defining your code, you want the layout to work so that you get nice alignment of the text in relation to your code. But you don't want all that extra white space. So depending on where you put the 3 double quotes, there's a question there.
So in the Java write once, run anywhere, is that a Unix new line, a mainframe new line?
I'm got to say I don't really know. Yeah, so you were talking about like character return line for
Yep.
I don't know. I guess whatever characters you use in your source code, that's what gets put in the string.
Does
It
that
does
break
convert to
the...
whatever format you do, it does turn into a new line in that particular operating system.
So that seems to... So when you compile it, if you compile it on Unix and run it on Windows, it's going to be a new line, not a carriage return new line?
It will do a CRLF on, I believe it takes in whatever the format of the operating system is. And
That it's running on, not that it's compiled on.
There you go.
Okay, thank you.
Yeah. So we have this idea of incidental white space, which is that the compiler will effectively ignore the white space if you have the 3 double quotes indented like this. But what's interesting is you do get an extra blank line at the end of your text. So if you put the 3 double quotes after the closing HTML, you will actually get the same thing, but you won't get your extra blank line. And you can also, if you want to move the 3 double quotes towards the left-hand side of the screen, then you can do that, and you can then sort of determine how much incidental white space is removed. So if you wanted to have all of this indented by 2 characters, then you just move the 3 double quotes over by 2 characters, and then that would add 2 extra spaces to every line. So there's a few sort of fiddly bits with text blocks.
I got.
Oh, yep.
So this is very similar to the JavaScript backend.
I guess so, yes.
So can you have like variable references or expressions within the?
No, it's not as complicated as that. No, this is purely about text. So no, there's no sort of replacement of variable names and dollar this and dollar that. No.
Also, there is a very good article by Brian Getz.
Yes.
Unless you're already mentioning it.
No.
There's a great article by Brian Getz which details what you should and shouldn't do when you use, long-form text in your code. We'll put a link out on the New York JavaSIG announcements after this.
Switch expressions. Okay, I've already talked about this, haven't I? So
yes.
Why would I come back to talking about switch expressions again? Well, I said that switch expressions were a preview feature, And the idea of a preview feature is that if something proved to be not very popular, that they still had the opportunity to change it. And it turns out that something was not very popular. People said, well, hang on, using break as a way of indicating which value is going to be returned from the switch expression is a bit confusing, because you can have break with a label, and you can break out to the label in that way. Now, the label cannot start with a number, so that's fine, so there's no ambiguity there. You can still do break with a number to return something, but you could also break to a label. So they said that doesn't really work so well. So in JDK, what are we, 13? Yeah, JDK 13, they said, okay, we'll change that then. So now we will use yield, and yield 6 rather than break 6. So small change, but it's good to see how the preview feature actually works and allows you to actually modify things before it becomes part of the standard. That was it for JDK 13. So I will mention a little bit about JDK 14 because we're actually in development phase of that at the moment. This will come out in February. But JDK 14 is shaping up to be quite a nice release. There's several things that are going into JDK 14 that I'm quite not exactly excited about, but certainly they're going to be good things that will make JDK 14 a better release than some we have. Records. Okay, this is an interesting idea. So finally, we're getting the idea of a record where we don't have to have all of the boilerplate associated with a particular class. We can do something like this. We can say record point int x int y, open and close brace. And that will effectively be the same as creating a class called point with two variables, x and y, and with associated accessor and mutator or get and set methods for getting access to those variables. But we don't have to write any of that code. So we simply say record int x int y, and that's it. We get everything else. So finally, if you like, Java gets a proper tuple in there. It's only taken 25 years. It shouldn't be really. And then there is the ability to make that a little bit more complicated, or a little bit more sophisticated, I should say, where you can say, okay, in this case I've got a range tuple where I've got a low and a high, but I want to have more functionality in my constructor in order to be able to make sure that the low value is lower than the high value. So in this case, I can add this type of code here, so public range, don't have to use the full definition of a constructor, because it knows that there are two parameters being passed, and then we can say, in this case, I want to have a test, say if low is greater than high, throw new illegal argument exception for that particular case. So there's a bit more you can do with it, but really you don't want to go much beyond that, because if you start going beyond that, you've essentially got a class. You might just as well make it a class. Pattern matching. Again, this is a preview feature. Last one was a preview feature as well. What this allows you to do is to go a little bit beyond how instance of works. Because in the past you would do if obj instance of string, and then you'd have to do a cast, wouldn't you? Because if you wanted to use it as a string, you'd have to take obj, cast it as a string, and then be able to use it in that way. But here, what we can do is we can say if obj instance of string, and then give it a variable, the compiler will do that cast and make that available to us. And so within that block of code, within that block of the if statement, we can say, print out s.length. And s is clearly a string, so we're able to use the methods of string because that's its type. In the else block, because we haven't got access to string s because it's not string, then you can't use s in there. So that's just an interesting small change to the language. And then this is probably the best bit, which is helpful null pointer exception. So anybody here never had a null pointer exception? Yeah, right, exactly. So we've all had null pointer exceptions, haven't we? But sometimes it can be quite difficult, because if we do something like this, a.b.c.i equals 99. Now, if that throws a null pointer exception, we're faced with a problem, because was it A that was null? Was it B that was null? Was it C that was null? So we don't know immediately. We have to then go back and we have to look at it, and sometimes we end up with lots of debug code. We have to print it out, or we use the debugger and things like that. So what we see is a message like this: exception in thread main, null pointer exception. We get the line, but we don't get any extra information about what actually happened. In JDK 14, hurrah! Exception in main thread, Java lang null pointer exception. Cannot read file C because a.b is null. Then we know where the problem is. So it immediately makes it life easier as a developer, because now we can figure out, without having to do all that extra work, what the problem is, and then go and try and fix it. A few other things that are going into JDK 14. So this is kind of the list at the moment. Obviously, this may change over time. Packaging tool, that's an incubator project. So this is a kind of replacement for the packaging tool that they used to have as part of Java FX. Non-volatile mapped byte buffers, quite a useful thing with when you're mapping things into memory and doing stuff like that. As I said, CMS garbage collector is being removed, and also the PAC200 tools and API, which are really part of the applet API and way of doing things, that's gone as well. Okay, just briefly to kind of wrap up, a few things about longer term JDK futures. So we've seen this sort of gradual addition of small changes to the platform, but there are also some ideas for bigger changes over a longer period of time. And as I said, Project Valhalla is one of these. And the reason behind Valhalla is that if you look at Java, we have an object-oriented language. We deal with classes, we deal with objects, great. But it's not a purely object-oriented language, because we also have primitives. And primitives were included right at the very beginning because of the performance of treating everything as an object. And so a decision was made that in order for Java to perform better, you needed primitives so that you had quicker access and an easier way of getting performance. So primitives, performance, objects, give us all the good things in terms of encapsulation, polymorphism, inheritance, and so on. But this has some restrictions, because it means that if we're using specifically like generics, you might want to do an array list of int, but you can't do that because you need an actual type for an object. And so you have to have array list of the wrapper class, integer, and then that has a whole lot of stuff associated with it, because if you start adding ints to that array list, you have to, the compiler will also box them into an integer object, put it into the array list, array, then it takes it out, you have to unbox it, get the value out, so there's overhead in terms of boxing and unboxing, plus you're creating lots of objects, and therefore there's that additional garbage collection load and things like that. So it's not the ideal way of doing things. In Project Valhalla, the current thinking, because this is still very much in development, is that they're going to introduce what are called indirect projections. And that will allow you to do something like this, where you can have an array list of optional int question mark, which will allow you to effectively have a type of, a type that is usable as a generic type, but in terms of its storage, it will be a primitive. So you won't have to have the overhead of the objects there. The other side of Project Valhalla is what they used to call value types. Now they're calling inline classes. And again, this is still very much a work in progress. And the current prototype that they have is actually introducing 2 new bytecodes into the JVM. So it's quite a big change at the JVM level. Default value and with field. And the idea here is to have something that codes like a class, but works like a primitive. So again, it's this idea of being able to store things more easily, get better sort of use of the space in terms of, you can think of it a bit like a struct in C. So if you only use C or C++, where you can have different fields within a struct, but that's treated as like one area of memory, and things are contiguous in memory, so it's better in terms of performance. So from a point of view of how it works like a class, you can have methods, it can have fields, you can implement interfaces, you can use encapsulation, it can be generic, but the really important thing is it cannot be mutated, so you can't change the values associated with it. Now, you would think that we can already do that in Java, because if you have a class where you make the instance variables final, then once you've set them, they can't be changed. Except they can be, because if you use a reflection, you can change anything you like. So they are truly final. With Project Valhalla, you will have truly final values in Java. You You won't be able to mutate them, and as a sort of as a consequence of that, you can't subclass them, and also you can't synchronize on them because of the effect of the monitor that you won't have. Project Loom is another thing that they are working on in terms of massively multi-threaded applications. And this is very good if you're doing web server type things where you've got lots of connections coming in that you want to process and be able to do that. Because what they found is that threads, mapping a Java thread to an operating system thread is too heavyweight. You can't scale up to thousands, tens of thousands of operating system threads. So Loom is going to introduce fibers. Actually, it's not. It's going to introduce lightweight threads. No, it's not. It's going to introduce virtual threads. That's the...
There is in talk from the DevOps Belgium, the Ron Prather, who is the lead of the Loom, said that there would be no fibers, that would be threads.
That is exactly right. Put it there. So originally they said they were going to introduce fibers, which was going to be the concept of having. So if you think in Java, you have a thread that maps to an operating system thread, and so the idea of having fibers was a way of having a different structure that would have multiple fibers mapped to a single operating system thread underneath. They decided they didn't need to do that, so then they started calling them lightweight threads, and then they decided that wasn't a good name either. So they've now decided, as of the last couple of weeks, that they are going to be called virtual threads. So that's the name. So from a programming point of view, they will work in exactly the same way as threads, which is nice because we don't have to kind of rethink things. What the JVM will then do is it will determine the mapping between the virtual threads and the operating system thread. And so you can have multiple virtual threads onto a single operating system thread. And the JVM will handle the scheduling, it will handle the context switching between the different virtual threads onto that operating system thread. Right now, they're in the process of adding continuations to the virtual machine. Continuation is essentially the context of a virtual thread. So it's the registers, the code, the values that are required to actually execute on a particular thread. And then they're using the fork join pool scheduler that was introduced back in Java SE 7, because that works very well, and they've already got that, so they can use it to make the scheduling and the context switching between those different virtual threads. The idea of this is that you'll have much lighter weight than threads, less memory used, and, as they've said, close to zero overhead for task switching. So the last bit I'll talk about is just very briefly is what we do at Azul in terms of Zulu. Zulu is basically our build of the OpenJDK. So we have the Zulu community, which is our free binary distribution of the OpenJDK. So I'll say that again, it's free. You do not have to pay for it. You just download it and you can use it. What we do is we take OpenJDK and we build that, and then we run all the TCK tests on it to make sure that it passes, and what we have built complies to the Java SE standard. We have lots of versions available, so we have 7, 8, 9, 10, 11, 12, and 13. I think our 14 early access should be out very soon. We don't have one at the moment. We have wide platform support, so you can get version Intel, 64-bit Windows, Mac, and Linux. For people who want to use slightly older operating systems, we also still have 32-bit versions for Windows and Linux, and we have ARM 32 and 64-bit. If you want to get that, you can go to Azul.com, download Zulu, and get it for free. And then, if you want to pay us money, we'll be very happy about that. We have an alternative version, which is Zulu Enterprise, which is the one that comes with commercial support. And so essentially what we're doing there is offering people who want commercial support for various reasons an alternative in terms of using Zulu. So right now we're going to support Zulu 8 until March 2026, so there's quite a long time left on that. We're also supporting Zulu 6, actually not until the end of 2019. I should change the slide. We have just decided that we're going to continue supporting that for another 2 years. And right now, as far as I know, we're the only people in the industry who are still supporting Java 6. So if anybody is using Java 6 and still wants to get updates to that, we can give those to you. So our idea is to follow long-term support release strategy. 9 years of active support. That means we'll backport fixes and do updates every quarter. And then 2 years of passive support, which means that we won't be issuing updates every quarter, but if you find a problem, we'll fix it and then give you a new version. And we're also doing what are called medium-term support releases, because we figure that 3 years between long-term support releases, there might be a feature that you really want to use in between. So the odd-numbered ones, so in this case 13 and 15, are going to have updates until 18 months after the next long-term support release comes out. So you've got 18 months to migrate from medium-term support release to the next long-term support release. If you want more information about that, you can talk to myself, you can talk to Merle, who's at the back there, who also works for Azul. So, just to summarise, Java does continue to evolve. Obviously, we're seeing a faster release cadence now, but I think we're actually seeing more features as well, which is really good because we're not having to wait years between releases. We're actually getting things in a very quick kind of thing. Every 6 months, access to updates is a bit of a consideration in terms of where you're getting those from. Lots of ideas for improvement in Java, inline classes, lightweight threads, syntax improvements, all those sorts of things. And like I say, Zulu Java from us as an alternative for open JDK builds. And with that, yes, this is what I was using in Germany in Russia. I should just say thank you there. So I don't know if anybody has any questions, so I'm very
I had 2 questions. One is about the text block.
Okay.
Yeah.
And, and the question is, so if I did triple quote A \n triple quote semicolon, would it output a new line carriage return on DOS? That seems like something I've wanted to do, where I wanted to.
I must admit, I haven't tested it.
Yeah,
So,
that sounds like a feature.
yeah, I would have to actually go back and check that because
Even if I didn't want the
Yeah.
other stuff,
Yeah.
that might still be a feature. The other question I had was about the, I can test this myself when I get home, on the garbage collection, the one that returns memory to the operating system. It's been more than 20 years since I used the BRK function of C to return memory to the operating system, but when I did that, I could only return the end of my memory.
right.
So I don't see how that gives you better performance, because the operating system is going to handle my memory for me, and if it's not, I'm not using that memory, it's going to swap it out.
Well, yes, it will swap it out. You're right because it will page it out.
Yeah.
Yeah, it'll page it out if you're not using it. So from that point,
I don't understand how that garbage collector is going to give you better performance by returning memory to the operating system.
Well, it's about. Yeah, I'm trying to think how best to explain that, but it depends on how much of the memory you're using in your box. Because, yeah, you're right. If you're not using it, it'll get paged out. But yeah, I can see what you're saying. That if you free it, what's the difference if it's being paged out? Because if you're not using it and it gets paged out, then it doesn't have any impact on the physical memory. Because other processes can still use that physical memory. Yeah, I must admit, I'd have to probably go back and ask the developers about that to see what their argument.
I'm asking you hard questions, I'm sorry.
Yeah. I'm sorry. Yeah, you. No, I got 2
Can you,
people directly in line. So
I'm having a hard time understanding why the struct types are immutable, because it seems like if you have a struct with, 5 doubles or something like that, and now I want to update one of them, why do I want to write 5 stores rather than 1 store?
Right. No. So this comes down to the idea of because it's also about value types. So they're not calling them value types, but it comes down to the idea of the big value types. So what you can think of is that, let's say you want to have an object that contains a number, and that number is 3. So you've got some integer object that contains the value 3. Now, if you've got multiple threads, all of which need a value 3, then rather than having to replicate that, and each one having its own instance of an integer object with 3 in it, you have them all point at the same one. So they all share that instance of an integer object that's 3. But if you don't have truly immutable types, then some thread could use reflection and change that to make it 4. So then the other threads that think they're pointing at an object that is 3 actually end up pointing at an object that's 4. Now, I see what you're saying in terms of a struct, but this is, Valhalla is more than just structs. It's about a variety of things in terms of improving the way that values are stored within the heap and how they're used by multiple threads. So there's a combination of things here. So it's not just...
So my question, are those on the heap or on the stack?
They're on the heap.
Oh, okay.
Yeah. Okay. Yeah, definitely on the heap. Yeah. So the question, yeah.
Is the new keyword in Java? Спасибо.
No, that was because I did this presentation in Russia a few weeks ago, and so I decided that I just hadn't forgotten that I use these slides in Russia, and normally I have thank you at the end, which is...
I'm curious about the inline feature that you mentioned before. I haven't played with it, so maybe I'm just missing something. But I can see where there would be a lot of advantages to how it's laid out in memory and all that stuff, so that it wouldn't be hit, that you wouldn't have any misses. And I'm just wondering if you think it's going to go the way of the old C register. Like, I'm wondering why it's like...
No, it's definitely not going to go the way of the C register, because I know exactly what you're talking about. So you say register.
Yeah, like, you as a developer know best, that should be all right.
Yes.
Sure.
And in fact, there was a presentation given at DevOps by the Valhalla, some of the Valhalla developers, and they talked exactly about that. And they said that the problem is that register became too much of a sort of solution. Everyone was like making everything register because they figured, well, you know, everything needs to be register, but we don't have enough registers, and so you end up with register. So this really is a register. And so things like that, no, they're definitely not going down that route of allowing you, as a developer, to indicate what, certain things about how you think the story should be done. This is about automatically handling that for you and making it more effective. So no, definitely not the idea of registers in that sense.
What's holding up string interpolation from being part of the, you said, no dollar signs. Is there some special reason why they don't want to do that?
I would have to say I don't know the answer to that without asking Brian Gertz. I guess it's just one of those things that they don't see as a priority at the moment.
Certainly one is it's evaluating compile time, not runtime.
Yes.
Okay, no other questions? Thanks again, Simon.
Okay.
So before you go, first of all, we've had a great year, so thank you for making the JavaSIG a great community. Thank you to Credit Suisse, thank you Sai for hosting us, that was fantastic. Thank you Azul for sponsoring the Java user group. We also have Vincent, if you want to talk about DevNexus.
Hey everybody, my name is Vincent Mayers. I run the Java user group in Atlanta. And I know these guys have given out some flyers, but we want to extend an invitation to NYJavaSIG members to come down to the DevNexus conference in February. Who's heard of this event? Anyone here?
I'll be there.
I'll be there.
No. So DevNexus is a conference that's been run by the Atlanta Jug for 16 years now, in one form or another. It's now the largest Java conference in the US. We expect 2,400 people next year. A workshop day with, 12 workshops, full day workshops. 15 concurrent tracks over the next 2 days. So, it's a great event. So we'll have an indie rock band playing at a happy hour. I mean, you can't beat that. So there's a 20% discount code on the flyer that you have, or can pick up at the back. And the other thing is, if nobody wants to go to JavaOne in the fall, we are running another event in Chicago in the fall, a new Java conference. which is going to be a fraction of the price of going to San Francisco. So the stars of the Java world will be speaking there as well. So again, check out the site and what's going on, sign up for updates, and see you in Atlanta.
Thanks, Vincent.
Thank you.
All right, so we're looking forward to a really good 2020. We have a lot of great speakers, just like Simon, coming up in the early part of 2020. So happy holidays, everybody.